Okay, so I will introduce my TotalBot 3 in Fiducial task. And this is my home, and this is TotalBot 3 I built. And now it is rotating to find all 4 fiducials. And after finding all of them, it will starting to find the first one, then the second one, then the third one, then the fourth. And these 4 fiducials have the ID of 0, 1, 2, and 3. So you can see this is the fiducial 0. And after finding the fiducial 0, the robot will move toward the fiducial 0. And when it is really near, it will stop. And then it will rotate the turn back to the origin point, which is the middle of 4 fiducials. So after the fiducial 1, it will continue to find fiducial. After fiducial 0, it will continue to find fiducial 1. So this TotalBot uses the USB camera, and it is not supported by the ROS. So the image will process on the TotalBot and then publish on the image topic. And I will use the computer to receive that image. So there is a delay. So I always let the robot like to wait 1 second or half second to make sure the delay will not influence the direction. So this is the fiducial 1, and after this will be the fiducial 2. So it is now making sure the direction is toward the fiducial 2. After this, it will move toward the fiducial 2 and stop in front of the fiducial 2. Then turn back, move back to the origin point. Okay, I will introduce my codes. And since it's the last assignment in this semester, and I use my TurtleBot built on myself and to finish this task. So there is a little problem that the image processing has a delay because I use a USB camera that is not supported by the ROS. So I cannot use the ROS package in the template. So I use a detect script to receive the image from that USB camera and to find if there is a fiducial and publish the position relevant to the camera. So this is the detect script. And this script is finished with the help of ChatGPT because it is truly out of my scope. And the main function is in this nav_rail. And I have 2 versions of nav_rail, which I will introduce this simpler one, which is there is no eliminate function, which is what I said, that there is a delay of image processing because the performance limitation of my Raspberry Pi board and the USB camera will need higher performance of processing. So the goal of our task, I will introduce this simpler script, and the actual script will be much longer, much larger, but the only difference is that the longer nav_rail includes the eliminate mechanisms to eliminate that delay. So to use like some, for example, to use some loss detection, low speed counter, blah, blah, blah. But that is not crucial and not the key point of our assignment. So I will use the original one, which has a much more clear logic. So our task is, we can divide our task in 2 parts. The first one is to find all 4 fiducials. The second one is to find one unique fiducial and move in front of it and back to the origin point. So to achieve this goal, I will introduce the first one, find all four fiducials, which is similar that we need a detect function to find if there is a fiducial, and if we find, we return its ID. So here I use a trick that I use a so it's here, the stamp, timestamp. Because when the robot detects several fiducials, it will publish 2 or 3 of them at the same time on the TF tree. So I use the recent one to represent the fiducial that is in the camera vision. So after detection of fiducial, we can use the scan for feeds, which is to use a set, and we use a loop to let the robot continue rotating. And once it detects a fiducial, it recognizes its ID and add it into the set. And if the length of the set is larger than 4, we stop this loop because we set 4 fiducials. So this is the first task. The second is to move to each unique fiducial and move to in front of that fiducial and move back to the origin. So here there are 2 main parts, the 3 main parts. 4, actually it's 4. So I divided them into 4 functions. The first one is to rotate until find the fiducial with the smallest ID. The second one is to allow the robot, the camera, face the fiducial. The third one is to move toward the fiducial and stop in front of the fiducial. The last one is to move back to the origin point. So the first one is similar as the first task. I will skip this one. And the second one, face toward the fiducial. So here, when we detect the fiducial, there will be a position, and that is a relevant position to the camera. So there are 2 positions we can coordinates we can use, which is X and Z. So X is the center of the camera, the distance between the center of the camera and to the fiducial. Z is the distance between the camera and the fiducial. So if the X is too large, we can make that X smaller one, and to find if our robot is faced toward the fiducial, and then we can use the Z, the distance, to make sure if the robot can stop. So after this, we can move to fiducial. We can use the P control and use that X, which is the difference of the direction, and to make sure the robot is always focused and move toward the fiducial. And stop at the Z. If Z is smaller, for example, 40 centimeters, it will stop. And after all of them, we will need to let the robot back to origin. Here, I didn't use my Atom script and use the TF frame because we have already published the frame of the fiducial, and that is relevant to the camera. So use TF will be easier and clear. Firstly, we get the current position, then we calculate the angle to the origin and rotate. Finally, we move back to the origin. So this is just like the first assignment of our semester, that is find the direction and move. So in the main function, we just use the scan for fiducials to make sure all 4 fiducials are in the environment, and use a for loop to find the fiducials one by one and move toward them and stop in front of them and move back to the origin. So this is my code. Thank you. 12点，赶紧剪辑了。